Hello everyone. So to begin with the overview, I'm going to start with just the form. And then in this video, I probably have enough time after discussing the form to show the deck class that I created. We'll go into the actual logic of it in the next video. But I think going through this bit of it is going to be long enough for a video. So we've got the normal boxes over here and the normal buttons that we've been using before. What I've added in here is, first we've got our labels here. I'm just calling it label select lexicon languages. For this, it's the text is actually select known languages because I figure when we're presenting it to a user, lexicons what I've been calling things behind the scenes, but they're not necessarily going to understand that. So saying select a known language kind of gives the understanding for them that this is the language that they're translating into, and the target language is what they're translating from. Then we've got these checked list boxes. So I abbreviate the beginning with a CLB. And we've got the selected lexicon languages, and a direct copy of it is the selected target languages. So these are going to be checked boxes, and the values will come in on there. Make sure that the check on click is true when you're coming through this. We want to have that be the case. After that, we've got what I'm calling the deck unlock order. And that's because as we're unlocking items, we're doing it in the order, and it's based on how they were created, the order they were created in the lexicon to start with, but that might not be the order that you want them to appear in. There's going to be a better solution for this in the future that I'll be making. Probably I'll have two list boxes, and you can just grab the possibilities from one side and arrange them on the other one. That way we can also hide cards we don't want and things like that a little more elegantly. Right now, you use the move up and move down buttons to change the order of them. And if you don't want a certain item, you can remove it from here. So again, these buttons are going to be called button move up, button move down, and of course, button remove selected. The list box here is just L box deck unlock order. Finally, down at the bottom, we need to have a save button. And so the button itself is just button save deck. And then the text box is the txt deck file name here. And before I forget, I do want to come down and change the multi-line to true. That way, when we use this, let me save that. Now it will no longer give the alert bell when we hit enter on there. And I do have that hooked up in the code, which we'll eventually get to, which will click the save button for us. The select mode is exactly the same, but I did add this unlock words. And you can see the button name is button unlock more words. I've abbreviated to unlock words so it's not too long on the text. And right now I've got it set where it's only going to unlock one at a time. But I think for the future, we'll probably end up doing a number box here, or maybe just a text box, and you put in the number of items you want to unlock at once. Anything that will make it more flexible for the user. The main thing is, for most people, you're not going to want to unlock too many cards at once. If you have a huge number of cards that appear, it's harder for your brain to remember them as you're going through. Adding in a card one at a time is usually an easier adjustment for your brain as you're studying vocabulary. So that's the main stuff that we're adding on here. I also do have this debug over here, which I'm just calling RTB statistics, because probably when I'm done with the debug data, we will actually use this to display some statistics. And I've got a text label for this, just debug box indicator here, but right now it's saying debug data here. And it just pops up if I need to use this while examining certain things while I'm running through the flow of the program to make sure that the values are set the way I want them to. I'm actually envisioning after we submit an entry and it calculates the new number and things like that, that we might display as sort of a progress bar instead, the current state of the word, and where you can have certain values set up where you like do not need to study more, or you need to study soon, things like that. We'll come up with arbitrary labels for that later just to provide feedback. But one thing I do want to get rid of for a user is the actual specific details of the card weights. That's what's going on in the background when you're doing it. But if you're actually using it, you only want to see the feedback of saying, do I need to study this card more? Should I keep it in, or have I already learned this one enough? And we can also set it where if you've learned enough, it can hide it from the deck so you're not being constantly displaying the cards that you're already super familiar with. So all of those values that we put in will be tweaked as we continue. But this gives us the overview of the new items that were put on the form itself. Let's go ahead and come over to the deck class itself here and see what we've got in here. So this class is a little bit bigger. Again, I'm probably going to change the name from deck to card because it started off with an idea of making a deck, and then I kind of just made this as an individual card with a list of these being the deck. So we will be dealing with that as we move forward. But for now, we got an ID. The ID is not really being used in this, but when we actually do construct more stuff with decks, it's possible we'll want the ID. So I still kept it in here, even though in the current iteration of this, I'm not actually using the ID for it. Then we're going to have the lexicon language and the target language right here. We need both of those languages just as a handy place to store it and print it out as we're going through. Next up is the lexicon word and the target word. Then we're going to have then we need the target audio link. So this is actually the file location of the audio. Then we've got a couple of Booleans here. So one is word unlocked and the other is hide card. Right now, hide card is not being used. The functionality is not being used, but I do have an intention for it, which we will be able to use to hide a card from a deck without deleting the card, and then making it where a user can later reactivate hidden cards and it will pick up without having them lost, without losing the statistics that they already had on there, such as time shown, the times correct, and all of that. And time shown and times correct are going to be part of how the weight value is going to be displayed. Right now, times correct is really just a metric that's being tracked, but I'm not incorporating it in yet. It's not even being displayed anywhere currently, but it is being tracked on cards. And ultimately, as I tweak the math behind how we determine what cards to be displayed, times correct will have an impact on the weight value that we're assigning to the card. Mainly, the more times that you've got a number correct and the more recently it's been shown, the less weight should be included on that card. Finally, we have the last time that the card was viewed here, and that is also to determine what the weight value is, because the longer time has passed since the last time you viewed it, the more weight that that card should have, so the more likely it is to be picked. Then at the very end of these, we have lists of the synonyms. So we have both the ability to have lexicon synonyms and target synonyms. And those I put at the end just because when we are creating and saving the data and then loading it again, we want these loops to be at the end. But you can actually put them wherever you want. It wouldn't affect anything as long as you account for them in the structure of your save and load files. After that, we then, of course, initiate these from the public deck here so that they have their default values and all of that. Then we've got a couple of public functions. There's not too many public functions right now. For the first one, we have a save all. So this just returns a Boolean. It's true when it's completed. It needs the deck of the list of these cards. So really think of deck as a list of cards here. And it's going to be all the cards. It passes in the username and then save file itself. The username itself is really just being used for this part of the file path so that we can make sure that the correct directory exists. And if it doesn't exist, we create that directory. The file name itself is going to be this save file that's passed in. And because I'm using the same code from before, I've assigned it to this file name variable here. We could have just used save file instead, but because we're used to using this and other things, I kept it consistent here. The output then comes through and we loop through these iterations just like we do before, field separators between everything. When we get to the loops, we're using the lexicon separator here again to separate out the lexicon items. And then at the very end, we include our line separators, loop through all of that, send it over to the save data. So this part is pretty standard how we've been doing it. It's just that this is now the difference of how we're constructing the file that's saved. And again, the username is only used for this part. We could build the save file based off of that, but because of the way that we can use the open file dialog to grab the actual location of the file, which includes the entire path to it, then most of the time we're going to be calling save all. We don't need that. We're only going to need that when we initially create the deck. So I'm handling that specifically on the part that's initially creating the deck. All the other times we're calling save all is after the deck has already been created. We've loaded it through the open file dialog, and we need to save the updates that we've made. So we don't really need this username to rebuild anything after that. So that's just something to bear in mind. When it comes to loading all, we do basically the same thing that we've done before. We return the list of these cards and we load in the file name. And of course, this, again, we do exactly the same basics that we've done everywhere else. So I won't go into too much depth here. It's just that you can see that we're now splitting up to field number 13 at this point. So there's a lot of fields that we have put in here, and we can come up and add more items and things like that when we need to. We create our temporary card, and then we add it to the deck here, and then at the end we return the deck. And if there is an issue, I do have it where it gives a message back to show that there was an error while we were loading this file, and we return null. So now we've got a couple of simple methods here. So we increase the shown value. We need the card that's being updated, and we increase the number of times shown by 1. And then we return true because it's done. Since the card itself has been passed in, it's already updated in the card. Same thing happens with the correct value here. So we just call these methods and it does this line. Again, these lines, because they're a single line, we don't really need them as their own methods, but I just put them in here in case we needed to call it from anything else as we're going through. It's just, again, something we can do, but it's not super critical. Then we get into the actual meat of what we're looking for in this. So we update the weight value of the card. We pass in the card that we're updating, and we pass in the value that we're updating it to. That's pretty straightforward. And then we just need to check, is it less than the minimum? If so, we make it the minimum. If it's greater than the minimum, we make it, or sorry, if it's greater than the maximum, we make it the maximum. So we keep a restriction on what the range can be. And as I put here in the comments on the side, we might want to make minimum points to be a negative number. It might be useful. In fact, I'm thinking of doing that. So we'll probably get to that at some point. But while this is the pretty straightforward way of updating this value, what are some other ways that we're going to be updating it? Well, first of all, we've got where we can update it by time. So when we have the time coming in, we're basically just grabbing the generate ID from here, because generate ID is, if you recall, just the number of milliseconds since the epoch time began. That's the ID that we're using. So that's already a time variable. We'll just generate a new one. And then we take that as the current time, and we subtract off the value that were stored as the time last viewed. That gives us the number of milliseconds that's happened between the last time it was viewed and our current time. We then will take that, and I've put these as doubles because they need to be doubles in order for the division to work correctly. And we take the increased value being set to the difference that we got up here divided by this variable, which is the milliseconds to decay. And therefore, what we need to have happen is a certain number of milliseconds need to go by. During that time, a certain amount of points will be added. And where that points come in is from here. So basically, this gives us the fraction of how many milliseconds, what's the difference between the number of milliseconds happened in the milliseconds to decay. So this can be a fraction of a number. It can be a whole number, or it can have a integer portion and a fraction, which is the most common thing once we've passed that value. We multiply it then by the amount that we are increasing per decay tick and add that in. And if it turns out that we've been waiting a really long time, this might be greater than the max wait points. So we're just going to make it the max wait points because there's no reason trying to set it greater than that. Even then, after we pass it in here, we then do this final check to make sure that if it goes over the max for the entire card, it's set to the max wait point. So that's the entire deck class. Let's go ahead and look at the FCP portion, which I've already highlighted here. This is the part that we are going to be using the variables for on these random weights control. So we default to having a weight of 100. When the card is shown, it gets a 10-point decrease automatically, just for having been shown, because you've seen it, so it's been exposed to your mind. Then if you get the answer correct, we take off another 20 points. If you get it incorrect, though, because it took off 10 points when you saw it, then we increase the 10 points back, and we correct for what you would have correctly had, a 20-point loss. Now it becomes a 20-point gain. So the reason it's 30 again is because it also accounts for this 10 points that was taken off just because you saw the card. The milliseconds to decay is set right now at 360,000. That is how many milliseconds are in an hour. So that's where that comes from. And the points per decay is 4. 4 points will cash out to you 1 point every 15 minutes. So as 15 minutes passes since you last saw the card, it will increase by 1 point. Feel free to tweak these to your taste. Same thing with the max weight points, which is currently set to 1,000. You can feel free to make this 1,000,000 or whatever you want it to go to for the max possible weight. And the minimum weight right now I have as 1. Below 0, the card will not be chosen if it's in the list. The weight needs to be 1 or greater for it to actually have a chance to be chosen. So just to describe really quickly the math that's going on behind this. So you see in the code in the next video, but the way that we do this is we loop through and we add up the totals of all the weights of all the cards. That gives us a total of whatever it is. So if, say we have 10 cards and they all at 100, then that will give us 1,000 for the total. Now, every card would have 100 out of 1,000 chances. So that's the same thing as 1 in 10 because there's 10 cards. But as you answer, a card decreases in value. So the total number of the weights will go down during that same thing because you just chopped off 10 for seeing it, 20 for getting it right. So that's a 30-point less deficit. But that first card is the only one that's having that subtracted out. So it's going to be less likely to be picked. So you can kind of think of it as buying a certain number of lottery tickets, with the caveat that, unlike the real lottery, a specific entry has to be chosen. So a card that has more entries to it is more likely to be chosen, but it's still not guaranteed. We're still playing a roulette where certain values have a random chance of being picked. And so it's not a guarantee. So you're going to get some variety. You might get the same card multiple times in a row because of that. And right now, I'm not putting in any checks to counter that, because I figure having the card being repeatedly shown to you is not a bad thing. That's basically the gist of it. You're wanting to refresh your mind. Having it randomly appear on there keeps your brain a little bit more nimble. But that said, we can also work at different algorithms on how we're going to tweak this moving forward to make it less frustrating to get the same card in a row, to make it more valid in a space repetition type of a thing as well. All of those variables can be tweaked, and they will be tweaked. It's all experimentation at this point. These are arbitrary numbers. I just picked them out of the blue. They're what are working for me right now, but even then I'm going to be tweaking these as I move forward. So this isn't the final at all. All that said, in the next video, I will go over Form 1. All the other code is strictly in Form 1 at this point. So now that you've got these classes, when we add them to Form 1, it'll work. But Form 1 is really long with the changes I've done. So that will take a whole separate video. So I'll see you in the next video.